to True Projects. In this video, we are going to discuss about the project which is fraud feature boosting mechanism and spiral oversampling balancing technique for credit card fraud detection. So before getting into the execution, let me give you an overview of the project. So you know how everything is gone digital these days. We are buying goods and services online more frequently and with greater ease than ever before, right? Well, with all that convenience, there comes a tricky problem called credit card fraud. So let's understand what is this credit card fraud. Imagine this, you have got your credit card details and these details are stored online for quick purchases. Now if someone suspicious person, he gets hold of these details without your permission, he starts swiping your card and uses all the money which you have. So, this credit card system is like a big network connecting banks, online shops, and payment processes. So, with all this data moving around, it is easy for fraudsters to slip in and use stolen information to buy all the things without your permission. That means he'll uses your credit card without your permission. It is like leaving the door wide open for them to sneak in and make unauthorized purchases. So, it is very important to detect this credit card fraud. So some of the existing methods they were used for detecting this credit card fraud. And those current fraud detection models, they faced two main challenges. They were feature redundancy and class imbalance. Feature redundancy, it happens because credit card data has lots of similar information. It confuses algorithms. Coming to class imbalance, it means that there are way more legitimate transactions than fraudulent transactions, making it hard for the models to learn. As a result, current models that are existing models often miss fraud information or wrongly flag real transactions. So to overcome these problems, the author in the base paper, he has proposed a way to catch credit card fraud using two main techniques. One is fraud feature boosting mechanism and the second one is spiral oversampling balancing technique. So coming to this fraud feature boosting mechanism, this helps in making sense of the data by getting rid of redundant and correlated features, making it cleaner and more useful. Moving on to the second technique, which is spiral oversampling balancing technique. This technique tackles the problem of having way more normalization transactions than fraudulent ones by creating more fake fraudulent transactions in a smarter way. It is nothing but we are solving the problem of class imbalance. So then to make further improvement in the performance, as an extension, we have proposed a model called voting classifier. So this model is an ensemble approach which takes the guesses from a bunch of different models and combines them to make a super accurate prediction. So by using this model together, they make fraud detection system that's really good at telling the difference between legitimate and sneaky transactions. So moving on to the flow of the project, first we explored and pre-processed the credit card dataset using Pandas data frame and cleaned it up. And then we visualized the dataset. Then we extracted important features and splitted the data into train and test for model building. Then we built multiple models that are SOBT, SMOTE, that is SMOTE, ADA, SYN, and Broadline SMOTE, paired up with some powerful models like Light GBM, XGBoost, and voting classifier. So after this, we have evaluated them using accuracy, precision, recall, and FN score. After training and evaluating, we have selected the best performing algorithm, which is voting classifier, and then we dumped it and deployed it using Flask application, where users can input data for prediction, showing the results on the front end. So moving on, to implement this project, we need software and hardware requirements. So coming to software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3. Front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. And moving on to the hardware requirements, we need Windows operating system, i5 and above processor, 8 GB and above RAM, and hard disk of 25 GB and above. So moving on, these are the algorithms which are built in the project. So all these algorithms, they are paired with different oversampling techniques. They are SOBT, SMOTE, which is mode, ADASYN, and broadlines mode. So among all these algorithms which are built, voting classifier, which is paired with broadlines mode technique, has performed well, so it is deployed it in the front end. So let us understand what is this voting classifier. Voting classifier is an ensemble technique utilized for detecting fraudulent credit card transactions. It is combined it combines predictions from different individual models such as AdaBoost and Random Forest to make a final detection legitimacy of a transaction of fraud. Each model independently analyzes various features of the transaction data such as transaction amount, location, and time to predict whether it is likely to be fraudulent or genuine. Voting classifier aggregates these predictions using methods like majority voting or weighted averaging to enhance accuracy and reliability in detecting fraudulent transactions. So now we will execute the project. To execute it, first we have to open the code folder which contains source code files. So this is the code folder of the project which contains source code files. So let's understand each file, how will it be used in the project. So the first folder we have is static folder. This folder contains files related to project styling and interactivity. These include CSS, JavaScript, and Bootstrap files. These resources are crucial for enhancing visual appeal and functionality of the project's web interface. This is the templates folder. Here lies all the HTML pages utilized in the project. They are index.html, about.html, etc. Each HTML file represents a different page of the website and provides the structure and the layout for displaying content to the users. And this is app.py file. This is a Python file which encompasses the front-end logic of the project. It handles server-side operations including processing user requests, interacting with the database, and dynamically generating content to be presented in HTML templates. And here in this file, which is credit card file, we have the data set. So this is the data set that is used in the project. And from V1 to amount are the parameters. Using these parameters, will be training the model to detect credit card fraud. So all these parameters are named as V1, V2, V3, V4, and so on, just for the confidential purpose. So this is the amount of transaction that they have done. And in the last column, we have class, which is target label, where we have two classes, that is 0 and 1. So here 0 means non-fraudulent transaction and 1 means it is fraudulent transaction. So we use all the data to train all the algorithms built in the project. So now close this. This is the model file which contain the algorithm information and it will be loaded into the project code during runtime. And this is notebook.ipynb file. This is a Jupyter notebook file which contain a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And here we have sample file in which we have test cases. So we use all these test cases to detect credit card fraud in the front end. So here are the extracted features from all the features. So using these features, we'll be detecting credit card fraud. So here 1 means fraud detected, 0 means it is non-fraudulent transaction. So now close this. And this is sign up file. This file is a database file which is used to store the user information. Now we need to copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now we need to open the Anaconda prompt. Using the command cd followed by the space, we need to paste the copied path and then click on enter. So here we can observe that current directory is changed to the code folder's path. Now we need to compile app.py file. So give the command python space app.py and now click on enter. This command will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port, unless configured differently. This is the local host and this 5000 is the port. Now copy this local link provided by the framework and paste it in any web browser. So I'm copying the link. I prefer Google Chrome, so I will paste it in that. Here we need to paste the link and now click on enter. So this is the web page of the project which is displayed in the browser, and this web page is built using Flask framework. So first we have to sign up, click on sign up and enter all the registration details if we are registering newly. I have already registered and have an account in it, so I will directly sign in. So click on sign in and enter username and the password. So I'm giving my username and the password. Now click on sign in. We have signed in successfully and we are redirected to prediction page. So we have to enter all these parameters for detecting a credit card transaction as whether it is fraudulent or non-fraudulent. So here in this Excel file, we have the test cases. We'll be using these test cases to detect whether a transaction is fraud or not. So here I'm going to copy the V3 value. I'm pasting it here. Moving on to V4, I'm copying it. The next value is V5. So V5 is 1.036265. V7, it is 0.36. Next is V10, so it is minus 0.2594. The next one is V11, so it is 1.080. The next one is V12, it is minus 0.37. The next one is V14, so it is minus 2.37. The next one is V17, it is 1.76. The next one is V26, which is minus 0.009. So we have entered all the parameters. Now we need to click on predict. So based on the provided parameters, here we got the prediction as the credit card transaction is fraudulent, which means that it is not a legitimate transaction. Now we will enter some more parameters. So click on prediction. So we will copy these parameters from the other test case. So we'll be using the second test case. It is V3 value is 0.65849. So copy it, paste it here. The next one is V4. So it is 0.37337. Moving on to the V5. I'm copying it. I'm pasting it here. The next one is V7. V10. The next one is V11. V12. V14. V17. V26. So we have entered all the parameters. Now click on predict. So here, based on the provided information, here we got the prediction as fraudulent transaction based on inputs provided, which means that the transaction which is done, it is fraudulent transaction. Now we will try using the other test case. So click on prediction. So this time we'll be using third test case. So I'm copying the V3 value. I'm pasting it here. The next one is V4. I'll be entering all the values. V5, V7, V10, V11, V12, V14, V17, and the last one is V26. Now click on predict. So here, based on the input provided, we got the prediction as non-fraudulent transaction, which means that the credit card transaction which is done, it is genuine. So now we will try using some more test cases. Click on prediction. We'll be entering all the parameters. I have entered all the parameters. So you can see all the parameters are entered. Now click on predict. So here we got the prediction as fraudulent transaction detected. So it is fraudulent. The transaction which is done is fraudulent. So now we will try using some more test cases. So click on prediction. So this time we'll be try using this test case. So here, this is the V3 value. I'm going to copy it. I've pasted it here. V7, V10, V11, V12, V14, V17, and the last value is V26. So we have entered all the parameters. Now click on predict. So here we got the prediction as fraudulent transaction detected, which is not genuine. So we will try using some more test cases. So click on prediction. So we will enter all the values. So I'm copying the V3 value. The next value is V4, V5, V7, V8. Sorry, it is V10, V11, V12, V14, V17, V26. So here I have entered all the parameters. Now we will click on predict. So here we got the prediction as non-fraudulent transaction detected, which is genuine credit card transaction. So in this way, just by entering the parameters, we can predict whether credit card transaction is fraud or non-fraud. So now we will see the graphs of the project. So click on graph link. So here we have sample outcome graph, which shows the distribution of labels. So here 0 is non-fraudulent transactions and 1 is fraudulent transactions. So on x-axis, we have class labels, which is 0 and 1. And on y-axis, we have count of each class label. So moving on, this is accuracy comparison graph, where on x-axis, we have accuracy score of each algorithm. And on y-axis, we have all the algorithm names. Here we have precision score comparison graph. And here we have recall score comparison graph. This is FN score comparison graph. This is G mean score comparison. And this is AUC score comparison graph. Now click on sign out. So the project successfully implemented a voting classifier combining AdaBoost and random forest models to detect fraudulent credit card transactions, enhancing the accuracy and reliability. Through comprehensive feature analysis and ensemble learning techniques, it has achieved robust fraud detection capabilities, contributing to improved security in financial transactions.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.